Hello, my name is Eeshwari and today I'm going to talk about OxO, a recently developed biomaterial wound dressing for chronic diabetic wounds. So what are chronic diabetic wounds? In diabetic patients, deep wounds show characteristically slower healing and more infections as compared to healthy people. This is because diabetes is associated with hyperglycemia or high blood sugar concentration, which increases the production of reactive oxygen species or free radicals that cause oxidative stress on the cells, delaying their healing. Also, due to destruction of blood vessels at the wound site, there's a low oxygen supply that leads to a hypoxic environment. Both these factors lead to more infections and make diabetic wounds the leading cause of non-traumatic amputations in the world. Cryogels are porous gel-like materials made from a variety of polymers at freezing temperatures. They have high porosity because the ice crystals that formed during the gelation process melt away and leave behind a network of interconnected pores. This gives cryogels a large surface area per unit volume, which is a useful property for cellular matrix formation. This is a polyurethane chitosan-based cryogel that I made during my search project in Professor Ashok Kumar's lab. The OxO uses a multifunctional approach to target diabetic bone healing. Besides being biocompatible and biodegradable, it also has antioxidant properties due to ascorbic acid in its backbone that helps it neutralize free radicals and lower the oxidative stress in the environment. It also has calcium peroxide particles that supply oxygen, thereby combating hypoxia. It also has exosomes, which releases a variety of growth factors necessary for faster wound healing. Polyurethane was chosen for its biocompatibility and biodegradability, as well as its chemical flexibility for incorporating small molecules in its backbone. Its hydrophobic nature also makes it useful for oxygen supplying properties of the hydrogen. It, it is made of a polyol and a diisocyanate that react together to form a prepolymer. The antioxidant ascorbic acid was incorporated into the backbone of the polyurethane gel. Its molecular ring structure gives it an ability to scavenge electrons from free radicals and lower the oxidative stress in the environment. It also has calcium peroxide particles, or CPO, that supplies oxygen at the wound site. Calcium peroxide, when in contact with water, releases hydrogen peroxide, which further decomposes to give oxygen. This is a widely known oxygen supplying source used in biomedical settings. They incorporated exosomes in the glycogen, which were isolated from adipose-derived stem cells. Exosomes are cell-derived nanovesicles that contain a cargo of growth factors and cell signaling molecules that enhance cell proliferation and differentiation. This increases the rate of wound closure. This is how they looked under electron microscope. This is the scanning electron microscope image of the OxO, and this is the false colored cells uh, that can be visualized growing on the OxO. The OxO can be further modified by adding different growth factors and integrating biosensors, as well as expanding its applications to different types of wounds like burns and ulcers. This would require comprehensive clinical trials to further assess its viability. Thank you.